All right, let's do what we always do in here and greet each other properly. Good morning.
Good morning.
All right, here, this is my period 2 today from Great Oak High School. I'm Mr. Aynesworth, and we're going to get into section 3 on supply and demand. So we'll have our Desmos up and ready here. I'm just going to expand the lesson. I want everybody to get our red pen, too. We're going to put all the key concepts in red, and we're going to do everything else in pencil. So get your red pen handy, and we're going to talk a little finance and economics today. Nothing difficult, but finally get into some finance and business stuff here, and a little bit of economics thrown in here. Okay, so let's go for it. Let's read the problem as we always do. So Wayne's Widget World sells widgets. First thing is, this is a business term. So let's at the very top, let's define widget. All right, it's a business term used for any item produced. Okay, so a widget is a general term for an item produced, and that item could be a computer, it could be a cell phone, it could be this Microsoft Surface Pen, it could be this pair of scissors right here, it could be anything. All right, so widget is a general term for something produced. That's all it is. General term for something produced. So you have to understand the vocabulary in business, so to understand what's going on. So let's reread the problem here. It says Wayne's Widget World, and the author always puts out really funky names here because they can't put in real names for copyright reasons, so they always make up something. And he tends to be a little bit goofy. So I actually met the author in a conference, and this guy he's pretty awesome. He's a doctorate, or he has a doctorate. He wrote this book here, and he teaches out on the East Coast, somewhere I think in New York. But anyways, Wayne's Widget World here sells widgets to stores for $9.20 each. That right there is called the wholesale price. So let's annotate a little bit. So right here, this is the wholesale price. Okay, the wholesale price is $9.20. All right, a local store marks them up for $8.79. That is called the markup. Okay, so we know the markup, we know the wholesale price. What we want to do is figure out the retail price. Okay, so it says right here, what is the retail price at the store? So here's our first basic concept right here. So let's put this in red too. So retail price is always equal to wholesale plus markup. Always. So put it in red. So wholesale, all right, price plus whatever the amount markup it is. Okay? So wholesale plus dollar markup. That's it. So a lot of the concepts that we're going to be talking about here are very straightforward and simple. The math is extremely simple. It's just conceptual. So if you understand what the concepts are, which we'll put in red, everywhere in our notebook here, should be pretty straightforward. All right, so we know the wholesale price is $9.20. We know the store's got to mark them up $8.79, which, by the way, why would a store do that? Why would they mark it up? Well, the Widget World sells them to the store. They got to make money. They're not going to give it to them free, so they need to make money. Doesn't the local store need to make money? Yeah. That's why they need to mark them up, so they profit. Otherwise, they won't be able to stay in business. All right, so there's always a markup. No matter what thing is produced and sold, there's always a markup by the time it gets to the retailer. So in this case, what we do is we take $9.20, all right, we add it to the amount markup, which is $8.79, right there. All right, and tell the person next to you what you're getting. See, and I heard everybody there. So $17.99. Okay. Now in this class here, we're going to deal with currency. Okay, currency meaning money, and when that happens, you might need to put a dollar sign on it. Don't leave it unlabeled. All right, and we're also going to be dealing with percentages. So when we deal with dollar amounts or percentages, make sure they're properly labeled, so you know what's what. Now we'll get to 2 in a minute here. I'm going to go to number 3 and then back to number 2 because number 2 depends on number 3. And I like starting with numbers first versus variables. So let's do 3 and then we'll go back to number 2. All right, so number 3. The Hockey Corporation sells hockey sticks at a wholesale price of 103. So that's the first thing we know, right there. We know the wholesale price now, so that's good. So let's just kind of outline it there. Wholesale price is known. The store marks it up 106%. Now this is a percentage versus a dollar amount, so this one's slightly different. So we know the markup percentage. So marks up 106%. The question is what's the retail price? So what we need to do is figure out the dollar markup. Okay, so second major concept of the day. So let's write it out and get your red pen again. Dollar markup. So how do you calculate a markup given a percentage? So for example, it says it's going to mark it up 106%, but what is that equivalent in dollars? So what are we going to do with this percentage to figure out how much money it represents?
Take it out of 103.
Say it again.
Take it out of 103.
Well, what do you mean take it out of it? Like, give me some mathematical operation.
Multiply by 1.06.
Multiply what by 1.06?
103.
There you go. So we're going to take the percentage and multiply it by the wholesale price. All right. So when you get a markup there, you're going to take the markup percentage, which in this case is 106%, and we're going to multiply it by the wholesale price. So in red, let's write it out. So markup percentage times wholesale price. So put everything, all the key concepts in red throughout the entire lesson, and then everything else in pencil. And so what stands out to you when you take a look at it later on are all the key concepts, okay? So Jameson said something important here. What are we going to do with that 106% before we multiply it by the 103?
Turn to decimal.
What is 100? Good. What's 106% as a decimal?
1.06.
Okay, so let's do it. Here we go. So you always convert to decimal. So this is 106%, all right, times 103. And that's going to be equal to 1.06 times 103. So do that, compare it with the person next to you. Everybody compare with your groups here. So Emma and Anthony, what are you guys coming up with there?
$212.
That's the final result. So just the markup itself.
First markup, $109.
Okay, so $109.18. See, I like the fact that you're working ahead. That's good. All right. So we're going to mark it up $109.18. And then the question says, what's the retail price? I mean, that's the end goal. So step one was find the markup. Step two would be to find the retail price. And Emma, how'd you do that?
I just added like the markup and the wholesale.
Okay, so right, we did that earlier, right? We took the wholesale, we had the markup here. So in this case, it's the wholesale is 103. We're going to mark it up $109.18. So we're going to add the two. Okay, so it's going to be 103 plus the markup 109.18. Emma, just take over.
$212.18.
Very good. Good job. Okay. Okay. You guys stop me if you have questions here on, I don't care how simple it is. You know, make sure you just stop and ask questions as we go. Okay? Now, if we understand that, then let's go back to number 2 and let's do it algebraically. The same thing in number 3, but applied to number 2. Okay, so the wholesale price of an item is W dollars. So the first thing we know is the wholesale price. So wholesale, W dollars. Okay, don't know what it is. This is an algebraic one here. And this problem here kind of lends itself to something that we would do, like if we're going to program it into Excel, okay, which we're going to do later on in a project. You need to write formulas in Excel, and so this problem is kind of just like that. Okay, the retail price is P% higher. Express the retail price algebraically. So to get the retail price, we look at number 1. It's going to be the wholesale plus markup. And then, so the question is, how do we get the markup? So first of all, Tell the person next to you what p% is as a fraction. Talk to each other. What is that? What's p% as a fraction?
P over.
Oh, yeah.
So in general, what's percent means what? Per what? Per 100. So 2% is 2 per 100. 6% is 6 per 100. 10% would be 10 per 100. But p% would be what?
P per 100.
Okay, so let's write that down in the margins just so that we have it. Okay, so p, let's put it down here. So p% equals p per 100. Okay, that's this part, p%. Okay, and now what we want to do is figure out it says retail price. So here we go. Retail equals is equal to wholesale plus markup. Wholesale price plus markup. Okay, so let's do it. All right, so help me out a little bit here. What's the wholesale price? You guys are being recorded. What's the wholesale price?
9.2.
No, read it. What's the wholesale price?
W.
W, okay? W, it's W, whatever that is, right? W dollars, all right, plus the markup. Now, we talked about in number 3, look down here at your key concept, the markup in general, you simply take your percentage times the price. Okay, so let's go back up to the number 2. What's our percentage?
P over 100.
It's P over 100, right? And then what's the wholesale price? W. And so to get the markup, you simply multiply them. So we're going to take P per 100, or P over 100, and multiply it by W. And we're writing what's called an expression, or a formula, if you will. So P per 100 times W. Okay? Now, if you were doing this on your own and you check it with the publisher's answers, it looks slightly different. So what we want to do is write this as one fraction right here. So how do you write P over 100 times W as one fraction?
PW over 100.
There we go. P times W over 100. So the answer looks like W plus PW over 100. And that's if we were going to program this into Excel, which we will later on when we do a little project, that's what we would write. Okay. Okay. Are we good on that so far? Are we good?
Yes, sir.
Yes.
Riley, are we good?
Yeah.
Be careful putting your head on the back wall there. You know why? Yeah, exactly. Did you hear that? Okay. I'm messing around a little bit. Okay. All right, number 4. Here we go. Let's check it out. So number 4, tire company sells bicycle tires to retailers for $2. What's $2? So what does that represent? What does that represent? Wholesale price or retail price?
Retail. Or wholesale.
Let's read the whole problem, and then if you don't know which, then let's read.
Yes, let's.
It says the Neola Bike Shop marks them up 80%. Okay, gotta make money. They're gonna mark it up. Express the retail price algebraically.
Which means the first
Guess
one
what?
is
We
a
don't know
wholesale.
what the retail price is, but if this company sells it to the retailer for $2, that represents what?
Wholesale.
Label it. Wholesale price is $2.
Label it.
You have to know what's what. If you don't, you can't solve a simple problem. So this is wholesale. This is why you see me diagram every problem that I work with. Because again, if you don't know what you're given, you can't use it properly. If you know what you're given, then you're more likely to, do something in the right direction. So we know the wholesale price is $2. It says the bike shop marks them up 80%. That's important. Marks them up 80%. Express the retail price. So here we go again. Retail price equals wholesale plus markup. Wholesale plus markup. The concept does not change, guys. We talked about this in number 1, and we applied it in number 2, and now we're applying it in number 4. Okay, so here we go. Let's let's deal with this algebraic thing here. So what's what's the wholesale price?
T.
Very good, $T, okay? So it's going to be T plus something, right? So T plus $T, this is in dollars, plus now the markup. Now the markup, look at number 3. The markup, any markup in dollars is found by taking your percentage multiplied by a wholesale price every single time. Now our markup percentage is 80%. Now 80% is what is a decimal?
0.8.
Very good. And we're going to take our percentage and multiply it by the wholesale price, which is
T.
so it kind of looks like 80% times T or 0.8 times T. Who's with me out there? Okay, so that's why it's so important to have your key concepts like big, bold, and red, so that just pops out at you. So 0.8 T. Oh, by the way, I wrote it as 0.80 T instead of 0.8 T. Are they equivalent?
Yeah.
Do we need the 0?
No.
No, not necessarily. Okay, so 0.80 T and 0.8 T is the same. Now we need to simplify this. We need to add T plus 0.8 T. Tell each other what that is. What is that?
0.80 T squared.
Keep talking.
Don't worry about it.
That's right, Jameson. Talk to your group. Talk to your group. Everybody. They're like terms, like variables, right? What's the coefficient of T? 1. So what's 1 plus 0.8? So the answer is 1.8 T. Okay, now let me share with you another way to think about it. So put your pencils down and get your eyes up. Because I don't do it like that when I do it in my head. Okay, so you're always going to have to pay 100% of something, the wholesale price. Let me repeat that. You always have to pay 100% of the wholesale price, plus whatever the percentage is, mark it up. So let's do some simple math in your head. So eyes up, you guys. So you're going to pay 100% of the wholesale price, plus whatever the markup percentage is, and in this case it's 80% markup. So what's 100% plus the 80%? 180%. You're going to pay 180% of the wholesale price.
That's it.
Now, what's 180% as a decimal?
1.8.
So what I do is I don't step it out in 2 steps. I take the markup percentage in my head and I add it to 100 because it's over and above 100 always, because it's a markup, not a mark down. If it was a sale price, you mark it down from 100. If it's a markup, you go above 100. So I just add that to 100, change it to a decimal, and you'll always get the end result right there.
Would that be acceptable to put? If, like, for example, you just did that, so you put
Yeah.
wholesale is 100 plus retail is
Yes.
180.
So if you did exactly what I said, and you just did in your head, that'd be fine. Because that's how people that understand what we're doing here, that's how they do it. You take the markup percentage, add it to 100, change it to a decimal, which is easy, and that's your end result. Okay? Okay. Are we good or are we good? I'm
Yes,
recording you
sir.
guys. Are we good?
Yes, sir.
Okay. All right, number 5. Now there's a little economics here. Who are my people in economics right now? Maybe with Fisher or someone else, right? Okay. Are there multiple teachers teaching the economics, or is it just Fisher?
Mr. Husband.
Mr. Husband as well? Who has Fisher right now?
I got the bid.
And who's got Husband? Is it economics or is it government right now? Government? Okay. So not everybody's in economics, so you might have, you probably haven't heard the discussion on supply and demand. But here we go. Let's see what you guys can do. Let's see if he's taught you some basics of economics. So the following graph shows the supply and demand curve for a widget. What's this P represent on the horizontal axis? Write it out, price. Yeah, P stands for price. If you haven't taken economics yet, P stands for price. So price, yeah, Q stands for what? Very good. So price is on the horizontal, and then quantity is on the vertical. Now, yes.
Mr. Fisher always says the price is on the vertical.
Right. So and if you watch the video in your video assignment last night, who remembers Alex talking about that, how in economics the axes are switched,
Yep.
and in mathematics price is always on the horizontal and quantity is on the vertical. And what did Alex in the video, what did he say about this, right? Why do we put quantity on the vertical as opposed to the horizontal in economics? What did he talk about?
Because the price is more of an independent variable than the quantity.
Yeah, quantity depends on the price. And because quantity depends on the price, we call that dependent variable. And in mathematics, the dependent variable always goes on the vertical. Like y depends on x in respect to a linear function. So y is on the vertical axis and x is on the horizontal. So in general, mathematicians always put the dependent variable on the vertical and the independent variable on the horizontal, and price is the independent variable. Economics changes it for some weird reason. I don't know why. I wasn't an economics major. Mr. Alex was. He was he either was economics or business. I was a pure math guy, so I can't answer why the economics or the people in economics do that. But it doesn't matter how the graph is shown, you can still get the same information from the graph. Okay, so let's do that. Let's figure out what we know. So let's explain what will happen if the price is set at $9. Okay, so let's plot $9. So, oh wait, before we do that, this point right here when demand meets supply, that's a special point. What's it called?
Equilibrium.
Okay, let's note that, okay? Okay, so this point here is the equilibrium point. Equilibrium. So what in the world does that mean though? Okay, yeah, it's where supply and demand intersect, but what more importantly, what does it mean?
They're equal. They're
Be more specific.
same value.
What do you mean? Be more specific. Supply is what in respect to demand at the equilibrium point?
Perfect relationship.
I'm talking about right here. At this point right here where they intersect, the supply is what in respect to demand?
So the producers are
Well, we'll talk about these two in a second here, but at the intersection point, supply actually equals demand in terms of the amount. Okay, so it's where they're equal. That's the only place where they're equal. Any other point, they're unequal. So write this down, supply equals demand. Supply equals demand. Now, when they're not equal, certain things happen. If they're not equal, either you have a surplus or a shortage, and that affects the price. So let's talk about that, because this is an open-ended question right here. It says what will happen. So let's analyze it, okay? Now it says what will happen if the price is set at $9. So if this is 5 right here, then 9 is obviously to the right. So if this is $5, then that's $10, back up a little bit. So let's plot 9 right around here. So kind of just estimate a little bit with me. So let's plot 9 here, $9 price. Now, put your pencil at $9 on the horizontal axis and draw a vertical line. Okay? Put sound effects in. Okay? So that vertical line hits the supply curve at point A, and it hits the demand curve at point B. And the question asks, what will happen if the price is set at $9? Okay, so well, first of all, let's just analyze it mathematically here. At point A, if the price is set at $9, it intersects the supply curve at point A, which is some quantity. Don't know exactly what it is because there are no units on here. All right, but which one's greater, the supply at point A or the demand at point B?
Point A, the supply.
Which one's greater? I mean, just look vertically here. Point A or point B? Yeah, I mean, if we had some units right here, this could be maybe like 300 and this could be maybe 100. Really don't know what they are because there's no numbers on the graph. This is a general graph. But definitely supply is greater than the demand at this point. So that's the first thing we know right up here. We know the supply is greater than the demand. Okay, so let's make note of that. So if the price is set at $9, then supply, all right, is greater than the demand. which means whatever we're producing and selling here, there's a greater supply compared to the demand from the public, which is you and me. So let me put this in a real context so we can make sense of this. All right, so let's talk grocery store for a second. So bring your eyes up here. Just who's been shopping for their family here and there? Okay, so let's take a very simple example here, like avocados, for example. We live right next to the avocado capital of the world. You guys know where that is?
Mexico.
No. I said right next to it, like 10 minutes away, south. Southwest, that way. No. Across the freeway, not that far, 10 miles. Fallbrook. Okay, so Fallbrook is the avocado capital of the world. And if you haven't been to the avocado festival, just get off at Mission and then go west a few miles, go down to Main Street, and they always have a little festival down there. It's really neat. But avocados are very expensive. Who already knows that? They also happen to be one of the most perishable items in the store. They don't have a long shelf life at all. Like you have to, when you buy an avocado, you have to use it within 3 days, unless you put it in the refrigerator or something like that and keep it cold. Otherwise, it's going to ripen. And so the shelf life for an avocado is very short, whereas a box of cereal can sit in the grocery store for weeks because it's preserved. Number one, it has preservatives in it, and it's also packaged, obviously. But an avocado has a very short shelf life. Now, what would happen if the store, like Sayer Brothers, doesn't matter what it is, they put too many avocados on the display? Too many avocados. There's not enough demand, not enough people going in there and buying the avocados. And so now, after day 3, day 4, they still have 100 avocados. What is that an example of surplus or shortage?
Surplus.
Okay, so they have a surplus of avocados because the demand is not there. The supply is there. Supply is greater than the demand because the public's not buying them fast enough. They're sitting on the shelf for too long. So after day 3, day 4, there's too many of them. So what's going to happen to the price of an avocado to get them sold? Drop the price. Now, right now, a typical avocado is $1.50 each, maybe up to $2, depending on the water situation. Okay, they're expensive. $1.50 for a little avocado. All right, so what they do is they're going to put them on sale. So instead of $1.50 each, maybe $1 each. Sometimes I've seen them as cheap as 50 cents. And then what happens when you go in there, assuming they're not overripe, people will just buy them up. So this has an effect. It says, what will happen? Well, in the case of an avocado here, if the supply of avocados is greater than the demand from the public, it's going to drive the price, what, up or down? Think about what I just said to the avocados. If we have too many avocados on the shelf and they need to sell them, what is going to happen to the price? Drop. So when supply is greater than demand, it's going to drive the price down, okay, in general. And that happens for anything. It doesn't matter what's being sold. Okay, so first of all, supply is greater than demand. Okay, that means there is a surplus. So the second point is, this means there is a surplus. Surplus means too many. That's the second point. I'm just making some notes here. So at $9, the supply is much greater than the demand. It means we have a surplus, like in the avocado example. And then that means that the price will be driven up, or price will be driven down? Price will be driven down. So let's highlight that. Price will be driven down. They have to lower it in order to sell the avocados in this example. Now, I just use the avocados as an example, just because you can relate to it, especially if you've been shopping before in the produce section. But it doesn't matter what it is in the produce section, whether it's cilantro, it has a shelf life of 3 or 4 days. Any of the vegetables in there have tomatoes, same thing, shelf life very, very short. If they're not selling, if the demand's not there, and they got greater supply, that they're going to drop the price and they'll put it on sale and to get it sold because they don't want to lose out on their inventory. Okay, now let's take a look at Part B. Part B says, explain what will happen if the price is at $2.75. Okay, so now let's switch colors here. $2.75 is less than 5, so let's plot it here. Okay, so here we go. Now draw a vertical line up. This technique is going to be used all the time. So you approximate 275 on the horizontal axis. It's obviously less than 5. So I plotted it to the left, and it intersects the curve at 2 points. We'll call them C and D. Now, because the curves are different, the supply and demand curves are different, which one's greater which one's greater now, the demand or the supply? Okay, at what point are you guys looking at?
C.
At point C. C is higher than point D, so the demand here is greater than the supply in this case. So now I'm going to have to switch examples from avocado to maybe, we'll talk about gasoline maybe. Okay, so now the first thing we know is that at this time, if we set the price at $2.75, okay, in this case, demand exceeds or is greater than the supply. So the first thing we know is that demand is much greater than the supply. So to understand this, I think gasoline, especially in today's world, is a very easy or really good example to use, because right now our supply is lower. The gasoline or the oil reserves is lower. And why is that? What's going on today? In today's world, what's affecting our oil supply? Can't hear you guys. You gotta speak up here. What's affecting our oil supply right now? Where? The war where? Yeah, in Ukraine. And who's invading Ukraine right now? Okay, and guess where we get oil from? Okay, that's one place we get oil from. And so right now we're not friends with Russia, are we? So we've really cut a lot of ties with them because they are not behaving really well in the world sense, right?
Yes.
Okay, and also, who knows that we're not opening up our own reserves and our own ways of getting oil here in the United States. We should be opening up new ways to get oil, but there are certain political groups prohibiting that happening. And I don't want to go into the politics, but we're not doing what we can do here in the United States to get enough oil to handle the demand, because we are one of the biggest world consumers of oil on the planet. Do you guys know that? Okay, especially in California, because we have more people in California per capita than any other state, I think, and we also we love driving alone instead of carpooling, so we have so many people on the road consuming so much oil and gas, it's not even funny. So right now you're seeing an example where the supply of oil, actually the demand for oil, which I mean gas, because oil or gas is made from oil refining. Okay, you got to refine oil to make gas. So the demand is there because there's so many people in California and other states, but the oil's not. So supply is greater than the demand for gas, i.e. oil, is much, much greater than our supply. So what's happening to the price of gas right now? Is it going up or going down? Yeah, fast, you know. Since all this started happening, the war, you know, Russia invaded Ukraine a while back, and maybe even further back than that, we've seen a spike in the gas prices. So that happens whenever the demand for something, I don't care what we're talking about, in this case I'm using gas because you can relate to it, is much, much greater than the supply, all right? We're gonna have what, a shortage or a surplus?
Shortage.
And if we have a shortage of oil reserves and gas, what's gonna happen to the price overall? It's gonna shoot way up, so let's write that down. So when demand exceeds supply, there is a shortage. Okay, so like in the gas, there's not enough, okay? And because of that, this is going to drive the price up. So price is driven up. Two totally different situations there. In business, we want to try to always get to the equilibrium price where the companies are happy and we're happy too, because we don't want to pay too much. We don't want to be paying too little either, because then we're going to have a shortage problem and deal with that. So finding that magical equilibrium price in business is super important for the consumers like you and me, but also for the companies too. So this problem here is a key problem. So noted in the margin, TQ. And in this class, what does TQ stand for? So you better understand the basic economics here, what's going on. Okay, let's get back to a little basic finance stuff. So number 6. So this book is a little antiquated. I forgot the copyright date, but it's got to be over 10 years old. But I think one of the best books I've ever seen in respect to finance, because it's so well written, step by step. You'll see that as we go through the chapters. So the automobile DVD navigation system sells to stores at wholesale price of $4.97. You know, back in the day, they were a lot more expensive. Now we don't even see those too much because we stream everything nowadays. And so, like I said, this is antiquated a little bit. But we're given a wholesale price, so underline that. It's key information right there. A popular national chain like store, maybe like Best Buy or something like that. And they don't use the names of real names because of copyright issues. So just keep that in mind. It sells them for, look at this, $879.99.
Dang.
Well, they need to make money, right?
Yeah.
So the company that makes them needs to make money, so they sell it to a retail outlet like Best Buy, but then they mark it up because they need to make money too. Because forming a business like Best Buy, there's a lot of overhead. Who knows what overhead means? No one. Okay, overhead is like all the costs associated to run a business, like the lighting, the employees, and many other things. So there's a huge amount of overhead. So it says, what is the markup? Very, very simple question. What do you do to the wholesale price and the retail price to find the markup? Let's do it. Here we go. So all you do is subtract. So markup here, okay, is found by taking the retail price, which is $879.99, minus the wholesale price of $497. Can you guys help me out with that?
Yes. 382.9.
There we go. So 382.99 or 99 cents. So just go ahead and set it up here. Okay, so again, wholesale minus, retail minus wholesale. So retail minus wholesale. That's all you do, subtract. Okay, pretty straightforward there. Okay, you guys jump in if you have questions as we go. Number 7, a guitar sells for a retail price of G dollars. Okay, so we have a retail price, G dollars. The wholesale price is W. Oh, you know what? I'm gonna skip this one actually. I want to go on to, I want to get to number 9, and I'm running out of time here today, so I'm going to skip this temporarily. Let's go to 8. Okay. Number 8. Oh, yeah. Okay, so automobile ski rack is sold to the stores at a wholesale price of $38. Okay, so we know the wholesale price. It has a markup, $23 markup. This is not a very realistic example because I don't know about you guys. If you ever bought a ski rack for your car, like, does anybody have one?
Yeah.
Which brand do you have? Yakima?
Yeah.
Or-
I think it's got that.
Yeah, it's either that or Thule or something like that. But they're, what'd you pay, like $200-300? Yeah, they're not cheap. Even the bike racks, they run out like around $800-900. So obviously this is a little outdated here. So if the rack wholesale price is $38, markup $23. Number 1, we want to find a retail price. So let's do that first. So retail price. Say it again, Patrick.
38 plus
So
23.
$38. Help them out, guys. Plus $23 is equal to.
61.
Okay, so there we go, $61. Now step 2, it says right here, find the percent of the markup. That's number 2, percent markup. How do you do that? What's that equal to? how do you find the percent markup? We know the markup in dollars is 23, but what percentage of the 38, the original wholesale price, does that represent? You know what I mean? So how do you figure out a percentage in general?
0.23 times 30.
Well, that's not a percentage. So in general, how do you find any percent? If you're given, like, if you're given the markup in general, which is a portion of the wholesale price, and then you're given the wholesale price in general, how do you figure out what percent the $23 represents? Because that's a dollar amount, not a percentage.
You divide the markup by the wholesale price, you get the markup percentage.
Okay, so divide the markup by the wholesale price. Let's write that down as a formula. So here we go. Let's write it as a formula. So wholesale price, or excuse me, markup, sorry. Say it again, Wade.
Markup price divided by wholesale price equals the percentage markup.
There you go. So here's your little formula here, if you will. So in this case, it's 23 divided by 38. Now that's just a decimal, guys. How do you change a decimal to a percent?
Multiply by 100, move the decimal.
So, yeah, that's right, multiply by 100. So let's put that in, actually. So it's going to be 23 divided by 38, and whatever that is, times 100. To get a percent, to change a decimal to a percent, you multiply by 100. If you want to go backwards, if you go from percent to decimal, you divide by 100. So, and then it says round to the nearest percent. So whatever you're looking at in your calculator, round it to the nearest whole number. Well, it's 60.5, but round it to the nearest whole number. Yeah, 61%. That right there is the percentage. This is 61% of wholesale. Okay, 60.5 rounds up to 61. Are you guys good with that?
Yes, sir.
So it's like the percentage is the same as the retail price. Is that just a coincidence?
Oh, yeah. You mean the number 61 and the 61 here?
Yeah.
That's a total coincidence.
Okay.
So just remember, this is a percent and this is a dollar amount. So don't worry about the numbers. Most of the time, they're going to be unequal. I'm glad you brought that up. Total coincidental. I mean, 99.999% of the time, that doesn't happen. So just follow this little formula here. Take the markup divided by wholesale. That will give you a decimal. And multiply by 100. And most of the time, these will be much different numbers. It's okay. Okay, last problem today, and then we'll do the rest in next session here. So let's read number 9 and let's try it. Okay, so a manufacturer takes a poll of several retailers to determine how many widgets they would buy at different wholesale prices. The results are shown. What is the equation of the demand function? Let's highlight that. What is the equation of the demand function? Okay, round the values to the nearest hundredth. Use the demand function to determine how many widgets to the nearest 100 retailers would buy at a price of $20. So the prices are, we'll let the X represent the prices here because we're going to use decimals here in a minute. And we're going to put this information into a table. We're going to let Y equal to the quantities that the retailers will purchase in the thousands. And then we want to predict this. Look right here. What would use the demand function to determine how many widgets, all right, which is in the second row here, retailers would buy at a price of 20. So here we go. Let's put price of 20 here, and then a question mark here. This is number of widgets. Okay. Now, if you look at the table before we even do this, let's use our common sense and predict something here, which is important. So look up here from left to right. Are the prices here increasing or decreasing from left to right? Increasing. Do you see 20 anywhere here in the table? In the data, 20 is nowhere. In fact, probably should have put it on the right side, or probably should have put it over here. Yeah? Because 20 is less than 23. So it's outside the data set. So we're gonna have to extrapolate instead of interpolate because we're going outside the data set. But look at here, if we go from right to left, if we decrease the price from right to left, what's happening to the number of widgets?
Increases.
It's increasing or decreasing from right to left? It's increasing. I mean, from 1,400 to 4,000, if you're going from right to left, they're increasing. So would you predict more than 4,000 or less than 4,000 if we set the price to 20?
More.
So it's going to be 4,000 something. Now we don't know what, but it's going to be greater than 4,000. So just keep that in your head, because if our answer is not over 4,000, then we did something wrong. Okay, let's go to Desmos, and then let's figure this out. So here we go. So notice I have my Desmos up here. By the way, you guys hit the save button. Make sure you save all your work because we're going to continue this on tomorrow, when we get back together. Hit the plus sign, select table. And what we're going to do is we're going to put the data in. Okay, so start entering the data. The wholesale price is in the first column here. And just go ahead and work ahead of me at your own pace, and I'm going to do the same thing here as you guys, as I always do. There's not a pattern here on the X values, so be careful there. Make sure you put the correct values in. These are the prices in here first. Then go to the second column underneath Y1 and enter in the quantities there, the number of widgets here. So starting with 4,000. So go work at your own pace here. When you're done, check your data set. See, I already made a mistake. What happened here? 26, 28, 28. Yeah, thank you. So I'm going to delete this. So 28, 30, 33, 35, 37. Now, come on, Aynesworth, what's going on here? 2550.
Good morning, Wolfpack.
All right, so what we want to do here to get our demand function is we want to use linear regression again. So let's write that down in your workbook here. So linear, so the demand function is linear regression. Well, we're going to use linear regression to do that. And what was that general function that we used for linear regression? Y equals mx plus b. So we're going to enter it as y1 is approximately equal to mx1 plus b. And we're going to type that in and get our linear regression line. So let's do that. So type in y1. Use the tilde, go shift tilde. All right, mx1, all right, plus b. And this will give you the linear function, which represents in this situation the demand function, where y is the number of widgets and x is the wholesale price in general. So we're gonna take the information here that we see, like m right there. We know m is negative 155.876, and we know what b is now, the what's called the y-intercept, and we're gonna write the function. So here we go. So y is equal to negative 155.876 times x, and then b is a big y-intercept, 7,428.85. So there's your demand function. It's a linear function in this case, right here. And what we're going to do is we're going to use it to predict the number of widgets sold in thousands if we set the price to 20. So, yes?
So I did the same thing you did and I got everything the same. But so just to check it, I put in like 33 that was on here, and it came out to 2,284, not.
Well, remember this data is not perfectly linear.
Oh.
So because the R value correlation coefficient is not -1, So it's not perfectly linear, so it's not gonna give you these exact values in the table, but it should be fairly close. That was a great point, by the way. I don't know if you guys heard that. He wrote the equation here in the second row, then he typed in one of these values in the table to see if it gets the correct y values. And he didn't get the same y value, you got something close. And it's because the data is not perfectly linear. If you graphed it and you looked at the graph, you'll see that. But you don't need to do that. Since r is not -1, it's negative 0.9 something, I know already that it's not perfectly linear. Otherwise it would have been -1. So I'm going to type in the actual function. So here we go, y equals, and we're almost done here. So y equals negative 155.876 times x plus that big y-intercept, 74,028.85. And then do you guys remember how to make a prediction here, what we do next? What do we do with our equation now that it's typed in?
Gear.
Plug and play.
Well, you could, I guess, but what did
Copy,
okay, so duplicate it. Well, how do we duplicate it?
Press the gear button.
Okay, press the gear, duplicate it, and then change it to a
Table.
table. And now delete these values because they don't make any sense. So backspace. And we want to predict the number of widgets when the price set at 20, so enter 20. And notice it says 4,311, and we predicted a value greater than 4,000, didn't we?
Yes.
And we got 4,311, which kind of makes sense. So here, so if x is 20, then our prediction y would be 4,311 approximately widgets times 1,000. This is in thousands because it says so in the table. So in thousands.
Mr. Ainsworth, would it be smart not to put like equal, but the wavy equal?
Oh, you mean like on the y value?
Yeah.
Yeah, you could do that. So approximately, let me do that. Approximately equal to, yeah. I agree with that because this is an approximation, not an exact value. Okay, I'll be right with you. Okay, so what we're going to do is we're going to end there, and then I'm going to resume in my part 2. I'll start at number 10 in our next session. All right? Good job, my friends. This is Mr. Aynesworth signing off.